To a casual observer, teaching often looks like the straightforward delivery of subject knowledge. But to a practitioner, it is an exercise in understanding the complex cognitive and emotional architecture of the child. Every child entering a classroom brings a distinct combination of abilities, experiences, and pacing. Aging does not automatically equate to learning, and physical progression is only a single metric in a multidimensional process. In developmental psychology, we separate two distinct concepts. Growth refers strictly to quantitative, measurable physical changes, increases in height, weight, and body size. Development, however, encompasses qualitative, continuous changes over a lifespan. It is the complex result of biological heredity interacting with environmental factors, like nutrition, family relationships, and peer interaction. A teacher who tracks only quantitative milestones will miss the broader picture. Designing learning experiences that cater to a child's cognitive evolution requires understanding how these qualitative changes unfold. While development differs for every individual, it follows a predictable sequence. Young children develop control over broad body movements before refining specific muscles, and they grasp simple ideas before graduating to complex reasoning. The sequence remains standard, but the rate of development varies wildly. Two children of the exact same age will hit motor, social, and language milestones at completely different speeds. This diagram illustrates the 6 major domains of development: physical, cognitive, language, social, emotional, and moral. They are completely interdependent. A child's physical health affects their cognitive concentration, and their emotional security directly influences their ability to socialize. These domains are continuously shaped by external contexts. Economic conditions, cultural expectations, family dynamics, and media exposure all accelerate or warp a child's developmental trajectory. Because these domains are inextricably linked, educators cannot judge a child's potential based on a single observed behavior or an isolated examination score. The assessment must be holistic. The Swiss psychologist Jean Piaget proved that children are not empty vessels waiting to receive information. They actively construct knowledge through environmental interaction. Piaget mapped this cognitive development into 4 stages. During the sensory motor stage, from birth to age 2, infants learn almost entirely through physical action and sensory input, eventually grasping object permanence, the understanding that an object exists even when hidden. From age 2 to 7, children enter the pre-operational stage. Language and imagination develop rapidly, but their thinking remains egocentric. They struggle to see situations from another person's perspective. Between ages 7 and 11, the concrete operational stage begins. Children develop logical thought. They can understand classification, sequence, and relationships, provided they can interact with physical, concrete objects. By age 11, learners reach the formal operational stage. Abstract reasoning activates, allowing them to form hypotheses, analyze possibilities, and solve complex, non-physical problems. The primary task of a teacher is to identify the learner's current cognitive stage. Instruction will fail if the complexity of the material does not match the child's developmental readiness. Lev Vygotsky approached cognition differently. He argued that development does not happen in isolation. It is actively mediated by society, language, and continuous social interaction. This diagram maps the zone of proximal development. The inner ring represents independent tasks. The middle ZPD ring contains tasks requiring guidance. Educators use scaffolding, temporary support like hints, to bridge this gap. As capability increases, scaffolding reduces, and the independent ring expands. Effective pedagogy does not happen in the safety of what a child already knows. It operates exactly on the friction point of the ZPD. Cognitive capacity is only one piece of the learner's architecture. Psychologist Erikson demonstrated that school-aged children require achievable challenges to develop a sense of competence or industry. Without these carefully calibrated challenges, constant comparison breeds a lasting sense of inferiority. Lawrence Kohlberg mapped moral development in a similar tiered structure. True moral reasoning is not built by demanding strict compliance to classroom rules. It requires actively discussing justice, fairness, and the actual consequences of actions. Howard Gardner challenged the rigid boundaries of ability altogether with his theory of multiple intelligences, rejecting the idea of a single, fixed biological metric. Gardner categorized a spectrum of intelligences, including linguistic, logical mathematical abilities, spatial reasoning, and bodily kinesthetic skills. Under this framework, a student failing a written exam isn't necessarily incapable. They may simply possess immense spatial or practical intelligence that standardized tests miss. Contrast these nuanced models with B.F. Skinner's behaviorism. While positive reinforcement does encourage desired actions, relying heavily on punishment only suppresses behavior temporarily, while actively breeding resentment and fear. Human intelligence, moral reasoning, and psychosocial needs manifest in radically different ways. A rigid, one-size-fits-all teaching methodology is scientifically invalid. Synthesizing these theories leads to constructivism. In practice, a constructivist teacher identifies a student's misconceptions and deliberately creates experiences that force the learner to reconstruct their own understanding. Instead of writing the mathematical definition of a fraction on a chalkboard and asking students to copy it, an active learning approach requires students to physically cut a paper pizza into halves and fourths to observe the mathematical relationships themselves. This approach requires differentiated instruction. Equal treatment in a classroom is rarely fair treatment. Fairness means providing individualized pathways, pacing, and support to ensure every learner can participate. Some of those pathways must accommodate specific learning disabilities, like dyslexia, dysgraphia, and dyscalculia. These are specific neurological difficulties related to reading, writing, and mathematics. They are not signs of laziness or low intelligence. An inclusive classroom integrates all children, regardless of neurodivergence or physical disability. This is achieved practically through multisensory teaching, visual schedules, accessible seating, and assistive technology. Child-centered pedagogy redesigns the classroom environment to fit the diverse needs of the children inside it, rather than forcing the children to conform to the environment. Learning requires sustained attention, and attention is driven by motivation. Motivation operates on a spectrum from completely external to purely internal. Extrinsic motivation relies on external variables. A student complies to earn grades, win prizes, secure teacher approval, or avoid punishment. Intrinsic motivation occurs when a child engages in a task simply because it is inherently interesting, meaningful, or enjoyable, like a student absorbed in building a complex bridge model solely to see if it will hold weight. This immersion depends on a specific environment. When a child fears that a mistake will lead to public humiliation or social comparison, their cognitive energy shifts away from the task and towards self-protection. Intrinsic motivation evaporates as soon as the cost of failure becomes an emotional threat. An effective teacher normalizes errors. Mistakes are not treated as moral failures requiring punishment. They are treated as expected, necessary data points that help analyze how a student is processing information. Long-term education must transition students away from a reliance on extrinsic rewards, allowing them to build a self-sustaining engine of intrinsic curiosity. This timeline charts the traditional model of education, known as assessment of learning. A student progresses for weeks without formal feedback, culminating in a single, massive red grading spike at the end of the term. This summative metric provides almost no actionable guidance for improvement. By replacing that spike with small, continuous feedback loops along the entire timeline, we shift to assessment for learning. This is formative and diagnostic, allowing teachers to dynamically adjust their instruction based on real-time data. Add a parallel process of self-assessment and peer review, and you achieve assessment as learning, where students are taught to actively monitor their own progress. This changes the practical function of the educator. They no longer act as a dictator of facts at the front of a silent room. Instead, they operate as a facilitator, a diagnostician, and a reflective practitioner. Good teaching is not a fixed performance. It is a continuous loop of observation, adjustment, and improvement, directly informed by how the learners respond. Every single child in a classroom is capable of learning, but every child will learn differently, at a different pace and through different methods. It is the teacher's duty to bridge that gap.